Hello everyone, welcome to a new Process Mining Café. Our topic today is data quality, and data quality is a really important topic for process mining. Many of you will know the expression garbage in, garbage out, so that is really what it is about. So if you analyze data that is incorrect, has problems, then also the analysis results that you're getting from that analysis will be wrong, right? So cleaning the data, finding those data problems, that's a really important step in any process mining project. And to discuss this really important and interesting topic today, I'm joined by two process mining researchers. Very happy to welcome, first of all, Kanika Goel. Hi, Kanika.
Hi, Anne. Thank you for the invitation.
Of course, we're very glad to have you. So Kanika is a lecturer in the School of Information Systems at Queensland University of Technology. So thank you very much for joining us from Australia. It's late in the evening over there, so we're really glad you could make it. Thanks for joining.
My pleasure. My pleasure.
And our second guest today is Niels Martin. Niels is assistant professor at Hasselt University and is joining us from Belgium. Hi, Niels.
Hi. Thank you for having me.
Okay, thank you both for being here. Before we start, I want to remind all of you watching right now that you can participate. So we have a chat where during the session you can add your own experiences, add your own remarks, ask questions, and we will keep an eye on it and try to pick up those comments while we are on the air. And so where you're watching this right now on the website, just below there's the possibility to join the chat. You don't have to have an account or anything, just type your name and enter the chat, and then you're in there and you can participate. So yes, we'll see you there. Now, to get started with this important topic of data quality, we actually start with a bit of a community contribution, because before we prepared the session today, I got some feedback from Jaap, who mentioned that in their organization they are using what is called the 6 dimensions of data quality to check data quality problems. So let me share an example for how that looks like. So that's a generic data quality framework. So it's not specific to process mining, but can be applied to any kind of data that you find in the IT systems. And it looks at general data quality dimensions like completeness, is the data complete, consistency, uniqueness, validity, accuracy. And there's actually a 6th dimension not shown in this example, which is timeliness. So how fast is the data updated once the real life situation changes. So it's clear that these are general important dimensions for data quality. And so like any data analysis technique, also for process mining, data quality is important. But so looking at this topic, it quickly turns out that it's not enough just to use these generic frameworks, right? Niels and Kanika, that was also your experience, right?
Yeah, that's completely correct. There's data quality as a research field. In general, it's an enormous field. So much research has been done over many decades. But indeed, if we look at these general data quality taxonomies, they're very useful because they provide a kind of a reference framework to think about the concept of data quality, which consists of different dimensions. But for process mining, partly because we also work with a specific type of data, it's maybe not enough indeed. And we maybe need more specific classifications of data quality issues, which are in particularly relevant for process mining.
Yeah.
Indeed, I completely agree. I mean, process data has its own unique requirements, which need to be understood and met when we are dealing with these different dimensions. So, yeah.
Yes. Exactly, and we will see some examples, like what does this mean, and we'll look at some specific typical process mining related data quality problems. But first maybe to really reflect a little bit again on what makes the structure of process mining data different from, let's say, regular data that you analyze for statistical analysis or data mining, right? We just, as a reminder, we wanted to highlight that again, because if let me bring up the example here. see. Yeah, so there it is. So that would be a kind of a common example, for example, for a classification problem in data mining, where you have multiple rows. Each row is one event or one learning example, you could say. And then, for example, for a classification problem, you need to determine what the classification target is. So to know that this is the grouping that you want to learn, and then you can derive rules or decision trees that learn when, for example, in this case, customers buy a particular widget or not. So that's kind of the classical situation. Now with process mining, it's a little bit different. And most of you will know this, but just as a quick reminder, we are not looking at like a single event as a full example or full learning example for the process mining algorithm, but we always have multiple events that are related, right? So in this example here, for example, you see one instance for the process mining algorithm is highlighted here as case 9705, and these are 4 events that all belong to the same case. So we need the case ID or process instance identifier to correlate all the events that belong to the same case, and then the timestamps to bring them in the right sequence, and then the activity name to describe the event. Right, and especially the timestamps, they are causing a lot of problems, right, Niels and Kanika?
That's true. That's a lot to worry about when you do real-life process mining projects. Indeed.
It's kind of, you could say it's the Achilles heel of data quality and process mining, the timestamps, right? It's a lot
and the
of things.
wonderful spaghetti models we get out of it.
Yeah, that can be an effect, right? That you have models that don't reflect anything. So maybe that's, before we go more into detail, that's maybe the biggest takeaway point for anyone maybe who's new to process mining, is that you really shouldn't go into the analysis before you're sure that the data quality is good, because then maybe you get a spaghetti model like Kanika just mentioned. You present it to someone in your organization and they find like there's a certain path in there or something that can't be true, and then you look into the data and it turns out, it's actually not a real path that happened, but it's due to a data quality problem that seemed to be there. So then you can go back and clean that problem by repairing the data, for example. But usually you have lost that trust to that person, right? So even if you come back and say now it's correct, they probably say that data doesn't really tell us anything. So it's really important to not skip over this step, but take it really seriously from the beginning.
Yeah, indeed, I fully agree, because people will lose trust, and if certain actions would be linked to some insights that they gather based on wrong data, that could even be detrimental, because I often work in the healthcare sector. I wouldn't want to make any decisions based on wrong data, because that could lead to dangerous situations or process changes. So that's something you should definitely avoid.
That's a very good point. It's not just, let's say, the kind of the selfish view of the analyst, like how they are taken seriously, but there can be some really serious effects and really bad consequences for people. Yeah, it's very good. Yeah, healthcare is a very interesting research area where also a lot of data quality problems can be found, but a lot of opportunity for process mining as well, right?
Indeed. The challenging part is often when the data that we use is gathered by manual actions of people, like a nurse, a doctor, or in other contexts where knowledge workers have to make certain actions with the system, and then that data is recorded. It might be that the data is recorded at another moment compared to when an activity has been executed. And then, of course, the timestamps in our event log, they don't not longer reflect the moment at which an activity was actually executed. So that's a pattern that I often see in certain domains, and that makes it, of course, very tricky for process mining, hence the need for good check of data quality.
Yeah, that's a very good example. And I think a nice example also to show a little bit the trade-off that you have to make between maybe having perfect data or data that's completely ideal and having some problems, but maybe still being able to use the data. So sometimes you have to decide that that's all the data that you have and you work with the data that you have. but maybe well, the time of the day doesn't really say anything, because it's always at the end of the day that the doctors are recording the actions of the day, like you just sketched in that example. So then you could still do the analysis, but you couldn't do it on a very fine-grained kind of hour or minute-based level, but based on a day level, for example. Yeah, but manual data collection is for sure one of the big drivers for data quality problems. It's like, Kanika, are you doing or seeing examples from a particular domain? Like Niels mentioned healthcare.
I mean, recently my projects have been in healthcare too, and I have seen some similar issues. I was going to point to another fact that this also brings into light an important thing about system design, because after all, healthcare professionals, the main job of one may argue that the main job of healthcare professionals is to take care of the life of the patient and not enter the data. I mean, if there are two things at that time, whether I want to enter data or maybe save the life of the patient, I would obviously, one would expect that the professional goes and saves the life of the patient. So this brings forth the significance of it's so important to understand what are the key causes or the root causes of these data quality issues that we are facing. So if it's manual entry, then there is a need to actually rethink about the system design and implement it so that the higher order objectives are met.
Yeah, exactly. Yes. And I think that's a nice point also to consider for improvements in the systems, right? Often there's not just one benefit. For example, if like you're saying, it's maybe manual work is also not the work that the healthcare professional wants to do. Like data entry is not what they work for, right? So they want to really deal with the patients. So if there's ways to design the system in such a way that the data can be collected automatically or directly by working through the system and not require an extra kind of data processing step later, that is better for the work, but also automatically improves the data quality, because then the timestamps reflect when something really happens actually in reality. So it's kind of, we're moving closer, right, to reality with the data in the systems. So taking all of these timestamp specific, but also other issues related to cross-mining into account, it's very good and very I'm very happy that in the research community there has been quite some attention actually to data quality. So it's not just algorithms, but it's recognized that it's a really relevant problem. So researchers in all kinds of groups have looked at different aspects of that topic. So today also what we want to do is we want to look at some of these categorizations that are more process mining specific, but also go through the steps of detecting, cleaning, analyzing data quality problems. And we want to look at it both from a practitioner perspective, but also revisit or point out some of the research approaches that exist in this space. And of course, afterwards, when we publish the recording of today's session, we will point to all of the papers and all of the materials that we mentioned, so you can read through them in detail if you want. So let's maybe start with the first categorization of process mining problems from a research perspective. So that was by a paper by J.C. Bose and Will van Aalst, and they categorized, let me bring that up here. Yes, so there it is. So they categorized it in different groups, like missing data, incorrect data, imprecise, and irrelevant data. And you can see the difference, right? For example, missing means that something isn't there. So for example, if for a particular event we don't have a timestamp, then we don't know when it happened. But the example that Niels mentioned before, if the doctor records some activity that they have done early in the day, later in the evening, then the time that is recorded for that activity in the system will be the time in the evening, but it's not actually the correct time if we're looking at the time when the activity really happened. So that would be an incorrect timestamp. And you can look at these kind of missing, incorrect, imprecise dimensions, not just for an event, but specifically for timestamps, resources, case IDs, and so on. So that's the categorization that was created. And so then based on that, Kanika, right, in your research group, they made another categorization that's more a pattern-based approach. So maybe you could tell us a little bit about that, how that compares.
Sure, yes. My process science research group at QUT has a long-standing tradition with process mining case studies. So through all the experience that the group has gathered over the years, they came up with these patterns that can be used to identify data quality issues, in particular for process data. So as we were discussing earlier, the dimensions that are there, they're good. Yes, they provide us good insights into the kind of data quality issues that we need to look for in process data. But these particular patterns gives you further insights into what are the kind of data quality issues that we have witnessed in the past related to process mining and process data. So for example, the first one, form-based event capture, that's an interesting one. So that's the kind of pattern that you see when you're using electronic forms. So there are multiple fields out there, and then it's very normal that when we are filling in an electronic form, you click on save. And then you want to submit it later. Now, because we clicked on save and then the submit button was clicked later, all the fields which were probably entered at different timestamps are logged at the same timestamp. So just imagine if you want to have a process model out of it, all of these are going to be in parallel. And we don't really get a good overview of what happens before and what happens after, which is what we want to do through process mining. We want to understand how the process is actually being executed when we are doing process discovery. But that's this particular pattern shows that this is not possible in such case. So these patterns helps one to recognize what are the key data quality issues that you can observe in process data, and what are the mitigation strategies that probably you could apply in order to prevent such issues, and what are the different detection and even repair strategies that one could apply.
Yeah, exactly. And it's like, it's a very, it's a very common problem also, right? This kind of form-based capture. So it's kind of illustrates this pattern-based approach where you're taking situations that you see frequently in reality and then define them in this way that people can recognize it, and you can kind of formalize and standardize the solutions for that. But I think also this form-based capture pattern is a nice illustration of how systems were created. Of course, not with the goal to create perfect process mining data, right? These systems, they serve a particular goal. So capturing the data was enough, and nobody was really thinking about whether the moment at which you capture the data that would be something that you would want to analyze later. So that's basically the root cause of this problem. And
it's a very important point that you touched upon, indeed, because we as process miners, we are really enthusiastic and passionate about it, and we sometimes forget indeed that the data that we have to work with comes from systems that are completely not designed for process mining, and that indeed leads to many data quality issues. So that's, in the enthusiasm of process mining, something that we sometimes forget.
Exactly, that's good to keep in mind. At the same time, you can also come from the other side if you're just focusing on how process mining automates everything and automatically creates the process maps, and basically sometimes people are not realistic and think the human isn't needed anymore to do the analysis, and that's not true. And I think the whole data quality area is a good area that illustrates that really well, because even if you recognize that there are some problems, you really need to still understand what's behind these problems, right? So having kind of a pattern library or experience as an analyst helps you to recognize that something is strange. For example, if we see here in this example that there are all these events which have exactly the same timestamp, we can have maybe the assumption or suspicion like, okay, maybe that's a form that's capturing these different fields. But still we have to know the underlying root cause, right? It's like Niels in the example with the doctor. We have to know like how the data is collected to judge the quality of it. So I think this kind of experience-based, pattern-based approach is something I find really interesting. It comes also close to how we look at the topic of data quality from a practitioner perspective. One thing that's really used a lot in practice are checklists, right? So, for example, if you fly a plane or during takeoff, I think the crew, they have different checklists that they go through, and it's just also in hospitals they work with checklists a lot. So it's a good and very practical way to not forget something, even if it's something that you do every day. It's easy to run the risk of skipping over something. So going through the checklist ensures that you just look at everything. So we always also try to create checklists for practical steps in the process mining project phases. And so one checklist that we've created also, and we, like we said, we will link to all of this also in the show notes, is this data quality checklist, where people can go through different things and basically check their data once they have imported it, to see if they can spot something that isn't right. And so I wanted to just pick one example to illustrate that. So, for example, when you're looking at the time frame, you can very easily detect a very common data quality problem, which is called zero timestamps. Now, zero timestamps are maybe timestamps that are 1900 or 1970 is the Unix timestamps, or sometimes it's in the future. So you might see timestamps like 2999 or something like that. So again, there's different reasons why in these information systems these zero timestamps exist. Sometimes they're kind of a default value for a data field that hasn't been filled yet, so people know, okay, it's not a real value yet, or it's some kind of initial value. But sometimes it's also some kind of technical problem. So you need to look at it. But for that, maybe I can actually just show that to you based on an example in Disco. That's, I think, the easiest way. So once you have imported your data, for this check on the checklist, you can just look at the earliest and the latest timestamp, right? So here, for example, in the upper right corner, we see the start, which is the earliest timestamp in this data set. And then we see the end, which is the latest timestamp in the data set. And here you see the 1900 timestamp in this data set appear. And it looks really strange, right? If we see there's a few events over here in the early 2000s, but then there's decades where nothing happens, and then there must be at least one 1900 event over here. So something is wrong, and it's a problem because it's not correct, but also it has effects on the analysis, and that's what we mean when we say timestamps are making those problems, right? We can see that. I have another example here where I can show that more easily. Again, also we have 1900 timestamp over here. If we're looking at the process map, then we see that most of the cases, actually almost all of them, they're started by this particular activity at the top, generic main flow. So that's kind of the start of the process. But then there's just one that's starting here, and also this path going backwards. So it's kind of an outlier, but it's not an actual outlier in the process, but it's, if we're looking at this zero timestamp here, it's something we can find also in the duration, actually. Maybe that's something I can show here. We're going to the performance view. For example, looking at the mean duration, that's another problem, right? We have a duration here for more than 100 years. Of course, these kind of effects you see with zero timestamp. And of course, that's a problem when we're looking at statistics. For example, the mean case duration is 13 weeks. But if we're looking at the duration, we see there's this one case which takes more than 113 days. And if we look at that, then we can look at that case, and then we see, okay, here's this first, it's actually just one timestamp, that's 1900, and then everything else is 2013 in this case. So we see that these things can mess up the analysis, both in terms of duration. So here the whole case takes 100 years, messing up the average or mean duration of the whole data set. These outliers can have a big effect on the mean, changing the maps. So that's the effect on the process maps and the variance, because the timestamps influence the sequence, right? That's why the timestamps are a little bit the Achilles heel of process mining, because everything is based on the timestamps, the variance, the process maps, the flows. And so that's really something that's important to catch and to repair.
Yeah, what your example also nicely illustrates is the fact that sometimes it's quite rigid, like we first do our data quality assessment and then we clean the data and then we proceed to the analysis. But this also nicely shows that doing process discovery can also help an analyst to identify these data quality issues. It can be helpful to see, okay, this is a strange pattern. Let's look a bit further into the data and then discover it. That can sometimes be more helpful than just looking at your raw data to identify these data quality issues. Use process mining as an instrument to help your own data quality assessment and then improvement.
That's true. So that's often, it's an iterative process. So you often, through the process mining tool, you are doing a lot of these data quality checks and investigations. But it's important that you don't skip this step and go right into analysis mode. But you're using the same tools. So for example, one of the things, once we have detected that there is an issue, like we see that there's at least one, right? We just know 1900 is at least one timestamp. That is a 0 timestamp, but we don't know yet how big the problem is. So to decide, and we come to this a little bit later, but to decide how to deal with this, we have to actually investigate and quantify the problem. So that's the first step, detection and quantification. And so for this, for example, we could use here the time frame filter. So if we go to the time frame filter, then at first we would just find out, basically investigate what's the scope of the problem. And then for this, we would use the intersecting time frame mode so that we catch all the cases that have at least one timestamp in this kind of area. And then, we would say investigating. And then we would see, actually, it's really just this one case, right? It's only this one case that has this problem. And we see that's the issue, and so we can clean that up. But there might be other situations. For example, like I mentioned before, sometimes future timestamps are used for kind of as a default value for activities that haven't happened yet. But it could be that it's an optional activity that might not ever happen, right? So then if you have a case, or maybe a lot of cases that have this particular timestamp, then you would actually just want to remove that one event and not the whole case.
I have had experience with data sets in which the timestamps were in future just because they wanted to anonymize things, and because of which they shifted the timestamps, and then the timestamps ended up being in future. So this is a common problem that I've observed in many of my projects. And I mean, in my case, I would we consider it as an outlier, discuss it with the stakeholders, and we'll talk about the remedy later. But it's more of an outlier detection kind of exercise, and then thinking whether we want to include it in the analysis or not, depending on how legitimate it is.
Yeah, exactly. That's a nice example. So here also, it's not actually a problem, but there's a good explanation for why that is. So then, you can just use the timestamps that's there.
Yeah.
Okay, so now we are basically in the first phase, right, where we have the detection of data quality problems and quantification. How big is the problem? So the interesting thing is that there's also some research approaches in this area. So we wanted to highlight some of those. And so here, Kanika, you brought a screenshot from one of the approaches. Can you maybe explain a little bit what we are seeing here on this slide?
Yes, indeed. So we were quite tired of doing these things manually, so we decided to build a plugin for it. So basically what this tool is doing is looking at the timestamps in particular in the data set and assessing the completeness, uniqueness, consistency, and accuracy of them. And we have different metrics to define these high-level dimensions from a process data perspective. So we were discussing these dimensions at the start of the session today, but the metrics that we use within it are very much specific to process data. So this is also one way how these dimensions can be articulated to process data and can be used to assess process data. And we have these dimensions categorized across the different levels of event data, which is event, activity, trace, and log. And then and then the input required for this is an event log, and it tells you how accurate, complete, and unique and consistent the event log is. At the bottom, the black panel that you see, if we click on any of the metric, it shows the it shows the traces or the events or the activities, depending on whichever level we click at, where the key root causes for the issues that have been identified, and then a domain expert can actually whitelist them. So it is an automated way of detection, but obviously we do need certain domain knowledge in order to ascertain whether these issues are actually issues or they're not. Also, there's an option to configure the weightage for each of the dimensions out there. So, for example, accuracy could be very important for healthcare sector. They may want the accuracy to be up to millisecond level or second level, but it may not be as important to be at the second level or millisecond level, let's say for banking sector. So that configuration, the weightage for each of the dimensions can be adopted based on different industries. So that's what this tool is doing. Basically, it's telling how accurate the timestamps are so that you have a holistic understanding of what needs to potentially be repaired, what needs to be further investigated, and have a good sense of where your data set is at the moment and how much data pre-processing efforts may be required.
Yeah. Okay. And is it a separate tool, or is it a PROM plugin, or how is it implemented?
It's a PROM plugin. It's log quality quantification developed by Dominic Fisher, and it can be used. An event log can be provided as input, and it can be used to assess the timestamp quality of an event log.
Okay, great. Yeah, we will make sure to link to that. So, for those of you who don't know it, so from Disco, for example, you can easily export the standardized process mining event log formats and then import it into PROM. So you can go from Disco to PROM and try out all the new research there very easily. So we will make sure to provide that pointer. Okay, that's really interesting. And you also brought another example, research example, right, Niels, from your group?
Yeah, that's correct. Maybe a bit of background where this came from, this idea, because a few years ago I was looking into the literature on data quality assessment, and there were some tools available that provide quite general insight in the quality of your data. But it was also important to recognize that data quality problems are often very context specific for the specific context of an organization. And I had this idea a few years ago, and there wasn't really an instrument available to detect such context-specific event log quality issues. And based on that observation, our research group developed DACAPO, which is an R package to support the fine-grained assessment of event log quality. And it's an R package, and it's part of the BUPAR ecosystem, which is the ecosystem in programming language R for process analysis and process mining. So what is that package, DACAPO? It's basically a set of data quality tests which can be performed on your event log. And the unique feature of this package is that each of these data quality tests can very easily be customized to a particular organizational context to really identify event log issues that might be relevant for your specific organization. And to make this a bit more specific, I brought two examples, of which one is shown here on the slide. So suppose I took an artificial example within the healthcare context. It sometimes is the case that within an organization that some activities are related to each other, meaning that if one activity is recorded, then another one should also be recorded for a particular case. So in this example, the test that is run is, suppose that activity treatment evaluation is recorded for a case, then also the activity treatment should have been recorded, because of course you cannot evaluate the treatment if no treatment has been performed for that patient. So this test supports that the domain expert states, okay, this relationship should hold in the data. They can run the test, and then the output shows that in this artificial event log for one particular case, patient 529, this relationship does not hold. So only one of the activity is recorded, but the other one that should be there isn't there. And then you know that this data quality issue is present, and then of course up to the next step to decide what to do with that.
Yeah, maybe a quick question here. So how do you decide what those configuration possibilities are? Is this also based on patterns or some common problems that you observe?
This classification, these tests were developed also based on literature review, indeed, where we started from a set of patterns which are defined in literature, but which also we experience in projects that we have done, like very common data quality issue that we came across. So that's, for example, where we notice, okay, sometimes indicate there are related activities that should both be present within a case. And then defining the parameters, which specific activities should be there, that's up to the domain expert. So this package is really developed to enter into dialogue with your domain expert as an analyst to really understand, because they typically implicitly know what the likely data quality issues are. And this way to extract this knowledge and test this on your event log, whether that really prevails, that data quality issue.
Yeah. And the second example is...
I brought a second example, which is a bit the data quality issue that we already discussed about. The fact that what is often happening is that several events are recorded in a batch at the same time. For example, because a resource does not have a computer available at a certain moment. And that creates that discrepancy between the time that an activity is executed and the time that an activity is recorded. So to identify that, this is called multi-registration, that kind of behavior within the Da Capo package. And this test is run, and you can see from the output that from this test, it seems that 25% of the resources conduct that kind of multi-registration behavior. And this is a hint like, okay, this could be tricky. We should really have a look at the timestamp to see whether they really show which activity has been executed at that point in time, or that it's just a matter of the administrative registration of that activity at a later point in time. Also, I often call this package like it has a signaling function, like raise some signals like flashlights. Okay, this is something you should look into, and then it's up to the domain expert to say, maybe they state, okay, this is no data quality issue at all, this is perfectly normal behavior, but then you're at least aware of these potential data quality issues that could appear.
Okay, so it's a little bit more like what Kanika was describing with the approach where the domain expert is maybe looking at the output and decides to whitelist certain things or says, well, that's actually not a problem, but it's more of an automatic way of scanning for common problems, right?
Indeed, it's an instrument to make some things. You could code it each time manually, but indeed this makes it much more easy if you get a new data set, because that's also my experience when working in different sectors. The same type of problems appear in different sectors. Some may be more problematic in certain sectors, but in general, you see the same patterns reoccurring. So if we can provide some support to identify these issues more easily, that's already one big step forward, because if data quality assessment is too cumbersome, then less attention will be devoted to it probably. So every tool to facilitate that process is, I think, a win for the community.
Absolutely. Yeah, I agree. Is that, Kanika, this kind of form-based capture problem, is that also part of the automated tests in the plugin that you mentioned? Or can you give another example, like for the automatic tests that are performed?
Well, I would say this one, and another, I would say a complementary example that we have been using is gamification. So, I mean, it's as Niels mentioned, that any kind of technique that we have for data quality testing is a win for the community, right? So just that's because it's difficult to get the domain experts involved, and even if forget the domain expert, even the people involved in order to make sure that whether the data quality, whether there is a data quality issue in the event log. So in one of the work by, again, our group here at QUT, we used the gamification technique in order to involve the domain experts to understand what are the, basically to detect issues in the activity labels and also to repair them. So we provide them multiple synonyms of activity labels and ask them which one would be the closest, and it's in the form of a game so that we can come up with a solution. Okay, for this activity label, this is the one which is mostly used, so let's have that in the drop down list so that people use that, or let's automatically use that for that particular activity which is happening in the system. So that's another technique that we have used in order to basically seek interest of people to identify data quality issues, which is indeed challenging. And any tool, as Niels mentioned, which is out there to detect and possibly repair such data quality issues is a win.
Absolutely, and that's yet another way to, maybe a creative way to detect problems, right? In this kind, in the form of a game. I can imagine that in a company setting that could work, right? That people,
in fact, so it uses crowdsourcing in a way. So instead of relying on one person, we can use multiple people and then aggregate the input of multiple people into one fine funnel output with, yes, okay, this is the answer based on the answers of, let's say, 100 people or 200 people. So it was an interesting solution.
I fully imagine that. Sure. That's a very interesting approach, because also indeed it's good to rely on a domain expert. You don't want to rely too much on a single domain expert, because indeed it might be that one person said, oh, this is not a data quality issue, while another expert would state something completely different. So indeed, I see a lot of potential in the approach, try to involve as many people as possible in the data quality step. Is definitely a win also. Because of course you have to be careful not to rely too much on the opinion of one person, and this could be a way to circumvent that.
It's true. It's like everyone is, it's biased, right? Based on what they just have seen, maybe in the past weeks, or what's still fresh in their mind. So it's the same problem with when you ask people to manually model a process, that you only get like a subset of the truth. And the same holds true if you talk about data quality problems that they suspect and that you might go hunt for. Yeah, exactly. So I think so far we have talked about the detection of data quality problems and how to find them, maybe how to quantify them, very different approaches to finding them, all involving the domain experts on some levels, right? Sometimes some automatic scans, but then with feedback at other times the domain expert defines what they want to see, and then the data is checked for those problems. And then once the problems have been detected, then the next phase is to clean and repair the data. So maybe, if we move into that phase now, so thinking perhaps back to the form-based capture problem that we discussed in the beginning, what would be some ways to repair or clean that data problem?
Well, one obvious strategy would be the events which have the same timestamp can be aggregated into a course event. So we can consider the different events with different timestamps as more granular in nature, and they can be grouped into whatever name the domain expert or the analyst wants to keep it as, and then you can discover or do the process mining analysis on that data set. That is one possible solution, but it may not always work, obviously, because you don't want to aggregate the events. But that could be one solution for form-based event capture.
Yeah, maybe this example shows is that there can be even, again, different forms or different, incarnations of this form-based capture problem, right? So depending on what the root cause is, you might find different solutions. So the aggregation, I could imagine, really would work well if you have a lot of events that are just recorded at the same time, but it's really something that happens at this moment, and then you aggregate it. So, you could, maybe another approach could be to take a representative event and let it stand for the whole group or something like that. But it wouldn't work if it's the same form that's used in very different parts of the process, right? So then,
indeed,
so then more work maybe is needed, and what could you do then? Then you would have to maybe look at which fields have changed, so that you can actually find out which field has changed to keep that and remove the other ones, right? Or
maybe for that, Niels and I were involved in a work where we have proposed maintaining annotations with the events at different levels, not necessarily events. It could be at event, trace, or log level. So in this case, we've proposed data quality and data transformation annotations. So and in data transformation annotations, they are related to any kind of insert, update, or delete that the user has made to the data. So if such annotations are maintained, and then they can be used to have an idea of if anything was inserted or updated at any point or time, or let's say, well, if it's deleted, it's deleted. But it gives a sense of where the data is going, and then that can be aggregated at the log level to understand which events could be representative of the issues that we have seen through the data quality issue. Which representative event can replace the data quality issue that we have observed in the event log. So that could be possibly another solution. Niels, do you want to add on something to it?
Yeah, but in general, it's not so easy that data cleaning, tackling these data quality issues, because in the end, you often rely on heuristics. The heuristic is developed to tackle a specific data quality issue, but what I see in literature, there are many valuable approaches developed to tackle very specific data quality issues, but they often have to make quite heavy assumptions, especially if they're more and more automated. They have to make heavy assumptions. For example, sometimes the process model is needed to, for example, rearrange the order of activities. That's not so easy to have that process model available to give that as an input to a method to improve data quality. So it's really tricky, data cleaning in general. We have to be very careful about that. And also here, the role of the domain experts, I think, really indispensable to really, they are the experts. As an analyst, you typically follow the process from a bit more from one step behind. And it's really important to really try to capture that knowledge of that domain expert to try to come up with some solution for data quality issues, remaining always aware that it remains fixes and will always remain suboptimal compared to recording the data correctly in the first place. So that's some mindset that you always have to be taken into account when you're doing data cleaning.
Yeah, exactly. And also to understand what the root cause behind it is, right? So there could be different ways to solve it. So if I think back to the 0 timestamp, then like we mentioned before, you would remove the whole case if there's just a few that have this problem. But if there's maybe 40% or so of the whole data set where just one particular activity has this problem, you would maybe rather only remove that one activity, but you have to understand like the pattern to make the right decision. So that's what the domain expert has to provide.
Yeah, totally agree.
But with these annotations, that's really interesting. So maybe to make sure we understand what you're saying there, is this something that is where you annotate the data based on the cleaning activities that you have taken, or also based on observations that might not be cleaned but are just facts, let's say?
So the annotations are based on any operations that would be performed on the event log, and also based on any data quality issues that have been observed. For example, we have proposed annotations for accuracy, and in fact, we have used J.C. Bose's framework to propose the annotations. So we propose annotations for preciseness, accuracy, relevancy of the events, and that again, we need domain knowledge. And we, in order to assess whether an event is accurate or precise or relevant, and we maintain annotations up front in order to assess the quality of the event log. So that's on one side, that's for the data quality aspect. But on the other side, we also say that if there are any kind of activities, updates or inserts, then we want to track the changes that have happened. So in order to maintain a lineage or provenance, which is also, I think, important for data quality, because in the end, you want to know what has happened to the data and what am I looking at right now that can really impact things. So for example, in one project that I'm working on right now, that particular company has issues with different departments coming up with different metrics for the same data set according to them that they're looking at, but based on after a root cause analysis, what I understand is that they are looking at completely different views. In other words, the lineage has not been maintained, and one particular department is looking at a completely different view of the data, and the other department is looking at a different view of the same data set, because of which they are coming up with different metrics. And then their matrix doesn't match, so the KPIs don't match. So one way to avoid that is to maintain a lineage. And while annotations are not the only way, we propose them as one possible way to maintain a lineage of the data set. So that's what we are proposing through the annotations.
That's true. And then maybe also to take a step back, why we also propose these annotations, because what sometimes happens is that a company goes through the process of gathering the data, identifying data quality issues, determining which mitigations actions are there, which data cleaning actions are taken. But then sometimes it becomes business as usual, in the sense that sometimes it's forgotten that certain changes have been made to the data by means of data cleaning. And what we would ideally want to do is to also take these fact that data manipulations have been done, also take that along during the analysis stage itself. And of course, the first step to be able to take it into account in process mining algorithms is, of course, that this information about data quality, data cleaning has to be captured in the event log. And that's also where the annotations then come in, because once it's embedded within the event log, also algorithms could take it into account in future work and take that data quality information into account when producing process mining outputs.
That's really interesting. Yes. So that basically brings us into the next phase, where once we have cleaned the data, we are analyzing the now cleaned or improved data, but there have been some changes have been made. So what you're saying, if I understand you correctly, is like basically to keep this awareness present for the analyst. The annotations can be there. And how can I imagine this in a practical way? Could this be, for example, attributes that are added to the data, so that if I look at a particular case, I see this extra information available in those annotation attributes? Is that how it works?
Yeah. Yes.
Okay.
Yeah, it's the next extension indeed, where that information can be captured. Maintained. So it's really in a standardized, structured way to also enable its use in subsequent analyses.
Yeah. Okay, very interesting. Well, we will link to all of the research we are discussing here. So that's a really important point, like analyzing the data once it has been cleaned. And it's also something that people have to be really conscious about, right? So if we go back to the simple example with the 0 timestamps, if, for example, 40% of the cases have this kind of 0 timestamp event in there, and we just remove all the cases that had the 0 timestamp in them, then we would be left with just 60% of the initial data set. But so maybe sometimes even there's no other way. So in this case, we could have just removed the event, which would have been the correct way to do it. But you could also imagine other scenarios where you actually maybe have to throw away half the data of the data set. But how representative is that data anymore, right, after making this step? So that's something that people really need to be very consciously looking at once they start analyzing the data. Well, how much of the initial data am I now analyzing, and is this still representative to what I want to analyze? And so the annotations can also help with that.
Yeah, indeed, and also just keeping track of them, like having a log available, not an event log, but just a document available, but it's very transparently mentioned which data cleaning efforts were done, that they're also discussed within the team involved in the analysis, like, okay, but is this a good step to do, and thinking jointly about the implications of certain of these decisions. I think it's really valuable to spend enough time in that stage, because it will have an enormous impact on your analysis and your outcomes, and subsequently the actions that you might draw from the process mining insights.
Yeah. So do you see this sometimes that people are maybe not so aware and are jumping, that they forget that they analyze clean data and that they're making mistakes? Or
I sometimes saw that pattern, like then it's business as usual. That phase is done, and now we proceed to the next phase. Yeah. But no, it's a continuous thing that you need to take into account. So I've seen that, and that's why I always really stress the importance of really taking that into account. We're not working on the original data anymore, and even if you have thought thoroughly about these data cleaning steps, it's important to really remember them, take them into account really until the end of the analysis and the interpretation of the results.
Yeah, it's not like a waterfall kind of approach. It's more agile in nature that we really need to go back and forth.
Yeah, exactly. Well, this then after the analysis, right, in a way where it brings us to this last phase, if we're thinking as a circle, right? You are analyzing data, you're finding data quality problems, you're cleaning them, you're analyzing the cleaned data, but then ultimately what you want to do, hopefully, is to improve the data over time so that the root causes for data quality problems can be fixed where they emerge. And so that's something that there's also there's actually also a research project that we wanted to share with you here. So let me bring up the slide for that. So that's something that has been work that has been done with your group, Kanika, right?
Yes, that's right. So this is the ODIGOS framework, which was developed in order to identify the root causes for data quality issues in process data in particular. So this framework is basically saying that the data quality issues that we observe in process mining are a result of the material, personal, and social world. Material world basically means the systems that we are using, application systems, whatever systems we are using basically comprise the material world. Personal world comprises the behavior of the people. Basically how they are actually interacting with the data and how much value do they put to the data. So data culture would be a part of the personal world, and then the social world is how people are positioned to interact with the data within the organization. And then the framework further says that the interactions between the material and social, material and personal and social, these interactions also influence the data quality issues that are observed in process data. So this is a framework which can be used as a starting point by people in organizations if they wanted to understand, to basically categorize if they, let's say, have a brainstorming session, okay, let's discuss what are the key data quality issues we are facing, and they come up with 20, 30 odd issues. They can use this framework to categorize, okay, this lies here, this lies here, this lies here, and this can then help them take appropriate strategies in order to overcome the root causes that they have identified for the data quality issues.
Yeah. I think what I find really, really interesting about this approach and this framework is that it really looks beyond just technical issues, because often we are looking at the IT systems and we understand maybe the systems weren't made to collect process mining data, so we can see some points there. But even stepping outside of the system, there's often in the interpersonal sphere, there's, like you mentioned here, social or personal factors that play a role, right? So, for example, one example I have to think of sometimes is that there was a process mining analysis being done in an internet company in Ireland a few years ago in a call center environment. They were looking at the customer service process, and so what they noticed is that all the cases that were created through incoming calls, they were closed very quickly and they were barely reopened at all, right? So it looks on the metrics that you measure typically in a call center is a metric called first call resolution rate. So you want to quickly solve the problem for the customer and do this fast and so on paper it looked great and all the reports were really good, but then someone noticed this and they said, well, it doesn't seem right? Let's look maybe from a customer perspective. So that's actually a nice thing you can do with process mining. You can shift the perspective from kind of the case perspective, which was like the issue or repair issue or customer service request issue, to the customer perspective. And then they saw that actually a big percentage of the cases that appeared to be closed quickly were not reopened, but they just opened a new request once the customer called again. And so it was bad on different levels, right? They don't have actual visibility on the actual process, but also for the customer, they had to explain the problem again, because every time you call and a new case is created, you have to give all the descriptions and things like that. So so that's more kind of the pressure here, is the incentive, like how are people measured? What are the KPIs that are used? And it's clear that the way you measure things can influence behavior. So that's kind of something completely in the social world. So it's really nice that this framework really tries to capture like the whole range of reasons that can be there for root causes.
Indeed, that's a very good example of interaction between the social and personal world. So KPIs would form a part of the social world, and then how people are behaving because of those KPIs becomes the personal world. So yeah.
And of course, for companies to use a framework like that to really look at the root causes, then gives them the chance to really, really prevent them and get good data for future analysis. And that's also something that we see in practice. Like we said in the beginning, it's not a good idea to wait for perfect data. Sometimes you find new companies who are starting to work with process mining to say, well, our data still has problems, so we can't do process mining, right? I think that's really a missed chance. You should start with the data that you have, but be really critical, like what the problems are and which parts of the data you can use. If there's areas which are too broken, then you can't use them. For others, you have to make maybe some judgment, like we talked with the physician, where you only maybe analyze on the day level, but not the time in the hospital. So that's it. But then still, as long as you can do something with the data, it can be useful. And so Jaap, who shared the data quality dimensions from the generic framework, that was, by the way, from the DAMA, Data Management Association in the UK. So it's an industry association. They made this guidance, and we will share that as well. So he also said, like, in their organization, how they look at data quality is that they think about data being fit for use. So it's like, what do you want to use this data for? And is it suitable for that? Are there certain decisions that are being based on that? Like Niels, like you mentioned, if it's really something that has big consequences, of course, the requirements will be much higher, right? So, I'm wondering, is that a dimension actually that's considered in one of the frameworks, like the importance of the decisions that are being based on the data?
Not yet that I'm aware of, but I don't claim that I know all the frameworks by heart. But I don't think it's taken into account explicitly. But I fully agree for that fit for use perspective is important to take into account, and also relates to the previous point that you made. Isn't it not? You don't have to wait for perfect data. I think that also using process mining on not perfect data can also help and be a motivation to improve data registration. If you as an organization start with process mining, do some initial analyses, and employees or decision makers really see, okay, this is interesting, that process mining that can help me in my job, that can help to improve certain things in my job. And then you would come to the observation, but if this and this data would be recorded in a more accurate way, that would even generate more potential for you to help you improve your job. And I think that's an enormous motivator and a catalyst to improve data registration in itself. Because of course, some people are a bit opportunistic, like, okay, what's in it for me? And by doing some initial analysis, they can see what's in it for them. So that's definitely also a catalyst to improve data registration in itself.
Yeah, that's a good point. So it can be a motivation, but also sometimes just finding out that there are problems can be a good insight, right? Even if you then can't use the data, like for example, the example you gave, Kanika, with the different views, where the two different departments had different views and basically different metrics. Well, that's something that's really good to know, so that you know where these kind of mismatches come from, right? That it's in the data.
Indeed, yeah. Another example is they automated some of the processes, and they were thinking that the data that's coming in is absolutely correct. There shouldn't be any issue. They have very good constraints, no problem at all. It's a very good data set. But then when you analyze it, you find so many data quality issues, as you rightly said. The fact that there are data quality issues are itself an interesting insight for some organizations. So just to give an example, that would have constraint for, let's say, customer name, and then they just didn't allow 2-letter customer names, and that's also possible. A customer could have a 2-letter customer name, and then because of that, customers were putting any name in it. Finding data quality issues itself is a good insight.
Yeah, absolutely. That's a nice example. Yes, so I think we have gone full circle through the whole detecting, cleaning, analyzing, and hopefully improving cycle for data quality problems. Towards the end, right, what we thought is that it's nice maybe to even one step back again and to look at to realize that data quality is just one piece actually in the whole topic of data management or data. Basically other data dimensions, right? So that's something that both of you together have also been looking at, right? So we put up an example for this here as well.
So interestingly, we are using the same, we are using the framework which is proposed by Dharma, which is, and you mentioned the data quality dimensions that were proposed earlier are also within the UK working body of Dharma within UK. But yeah, that dimension, as you can see in this framework, is one of the many dimensions that Dharma proposes. So Dharma proposes 10 dimensions for data governance. And one of them is data quality. So that's interesting, right? So we really can't get reliable data just by spending all the efforts on data quality. We need to look at many more things. And for example, data security, data modeling and design, where the systems come into play, interoperability, making sure that we can actually amalgamate the data from multiple systems, metadata, reference and master data. So some interesting dimensions, and what we did is we conducted a Delphi study with experts in the area of process mining, and to understand what are the key data governance considerations across these multiple dimensions, and we came up with this framework with 38 data considerations which are specific for process data. So what we have basically done is contextualize the Dharma framework in the process data context, and we identified the different considerations in order to ensure that we can actually trust process data. And interestingly, we came up with a new dimension which is supporting organizational policies and programs, which is not proposed by Dharma, but the participants conveyed significant for maintaining and governing process data. I let Niels speak further on it. Yeah.
It was really a joint work. So
yes, yeah.
No, indeed, it was very interesting topic to work on, because it really showed that if you want to benefit fully from process mining as an organization, you should really treat process data as a strategic asset. And if you want to manage it as a strategic asset, then all these dimensions of data governance are relevant. Data quality is an important one, but it really enlarged our perspective as well. Many other dimensions are also very relevant. And as Kanika mentioned, we came up in the end with 38 considerations, which the experts found relevant for process data in particular. And to give one example to illustrate it, for example, one item that came forward is that there's a need to also, in the data model of the organization, to capture the fields that are required for process mining. So it's really that process mining should be a point of attention as well when conceptualizing that data model at an organizational level. And so this is the item, and we also have an indication of how relevant the panel indicated that item was, whether it's strongly relevant, moderately relevant. So we have also an idea of that relevance score. Another example is that there's a clear need for guidelines on how to build event logs, which is also in another dimension. There's also a very typical process mining aspect, which needs to be taken into account if we really want to use process data as a strategic asset. And it also highlighted the fact that, okay, we did a lot of research already on data quality, and I think we already came a long way, but more work needs to be done. But also in this other dimension, there's so much work still to be done. So as research, we will not get bored in the coming years, that's for sure.
Oh, sure.
Absolutely. I can see that. Yeah, exactly. I think it's so nice that basically we have come back to the beginning where we see, well, there are frameworks, there's bodies of knowledge, there's guidelines for data quality, specifically already from other areas. But we do need some specific guidance for the process mining world because there are some specific characteristics with the process mining data due to those temporal relations that we reflect in the data. And it's really interesting to hear you both report on this data governance, broader data governance perspective, that basically you have not found this only in the data quality, but in all of these dimensions, that there's special considerations for process mining. So indeed, a lot of work ahead of us as a field. Yeah, so that's, I think, a really nice place to end. Is there anything else that you wanted to add, or anything you wanted to say to the community in the end?
From my side, I think that the last years we already made a quite nice evolution in this topic, because when you also see it when you put the timeline across the publications that were also mentioned during this talk that we had, you see that we really moved step by step as process mining as a whole matured. Really, this topic also matured. We went from having some categorizations, we have operational tools to detect issues. Now we're moving more towards that root cause analysis, really identify what are the root causes. So I think we just have to keep on making that progress as a community, because it's such an important topic. But I really notice that the entire community is also very aware of the importance of this topic. There's also at the upcoming ICPM conference a workshop on the topic of data quality. So it really highlights that it's no longer one or two researchers who work on that topic. It's really becoming a core component of the community. And I think also practitioners and academics need to really come together and make sure that we have really nice tools to detect data quality, to improve data quality, because it's so important, as mentioned at the beginning, garbage in is garbage out, so we have to take it into account.
Exactly, yes.
Yeah, Niels has summed it really well. I'll just add from a practitioner perspective that if the analyst is spending a lot of time on data pre-processing, I think it's worth it, because then analyzing insights won't take much time and you can actually rely on it. And as Niels mentioned, there's been a lot of research in the past few years, so it's not a bad idea to look up for different tools and techniques that may be available for the kind of data quality issues that you suspect in your data set. So, yeah.
Yeah, I really like that closing note of yours, Kanika, because you mentioned these 80% of time that people spend on data preparation. That typically includes the checking of data quality problems and cleaning of data quality issues. And I think today we have seen once more that there's actually a lot of value in this phase. So it's not like 80% non-value, but there's actually a lot of value in this part of those 80%. So it's a nice way to look at it. All right. Well, thank you both. Thank you, Kanika. Thank you, Niels, for joining. It was really nice to get this overview from you and be briefed about what's going on in the research world. Thank you.
Thank you for giving attention to this important topic.
Yes.
Thank you.
Great. And thank you all for watching and joining us here today. As always, we will publish the recording in 1 or 2 weeks or so with all the pointers that we mentioned. And we will be back with another Process Mining Café in October. And then we will be talking about the process of process mining. Stay tuned. Bye-bye.